Hello friends, welcome to my channel. In this video we'll discuss the full sectional front view of this object. It little bit looks complicated, but if you'll see it carefully here, due to this large size arrowheads, it looks congested. So, otherwise the drawing is very simple. We'll discuss this now. So in this drawing the direction of view for the front is not given. So let's say this one is the direction of view for front. The maximum dimension is the front view, right? If the direction of view is not given, so you have to consider largest dimension as a front view. So if this is the front, this will be the left hand side view and this will be top view of the object. So we have to draw its full sectional front view. Full sectional front view and top view, right? Left side view is your assignment. So if you want to see full sectional front view, how to cut this object? This is the direction of view for front, but we want to see sectional front. So we have to cut this object through this path. From here we have to section this object. Here is the cutting plane. Chain line with thick end. So it's not given to us, so we have to assume the cutting plane here. Through this path you have to section the object. Now this is the front view, but if you'll cut this object, it will be now full sectional front view from this direction. So basically for full sectional front view, we are cutting this object through this path. This portion will be removed and we have to keep this portion. And it's an imaginary cutting plane, right? In actual, the object will remain there. We assume that we have removed this part, 50%. So let's read the dimensions to draw the object. The very first step, like whenever you are solving any problem like physics, chemistry or any other subject, first you are reading the dimensions. You are reading the statement. So here we'll read the dimensions of the object. So let's read this. From here to here, total length of the object is 100. 38 is the dimension of this hole, right? This margin is 13 mm, means at 13 mm this hole will start. Now 64 is the width of this object. 50 mm is for this slot. From here to here it is 50 mm. So this is over dimension basically. 64 minus 50. So remaining is 14. So it is understood that both the sides will be 7 and 7. This height is 6. Total height of the object from here it is not given. Let's identify this. Yes, here it is given 19. Height of this part is 19 and total height of the object is 44. Let's read the other dimensions. In this part, this is 64. This was already given to you. So this is over dimensioning. This was not required here. This is over dimensioning. This one is 24 plus 10. After 10 mm there will be a circular hole. Circular hole this side, right? Next, again there is a circular hole of dia 10 and from this side it is 19. Total dimension from here to here is 38. 38 is the total dimension here. So at the half of 38, that is 19 mm, there is a circular hole. This circular hole is not at the center. Here the margin is given as 13. Here margin is given 13 this side, and from here it is 10. These are the coordinates. Dia is 10. Here it is given that 2 holes M6, deep 20. Right? Now the next part is 13. Yes, this depth is 13 mm. Now any other dimension? Yes, we have now read all the dimensions here. So let's start to prepare the drawing. Now first we'll draw the outline. See here, very simple trick is there. You have to remember only 3 simple tricks for the sectional view. First one is prepare outline, then identify cavity, and third one is hatching. Only 3 simple steps are there. Prepare the outline of object, identify the cavity or hollow part, and third step is hatching. So let's prepare the outline of this object. It is simpler than the orthographic. So very first we'll draw the this length of 100. Now the height is 19 this side. This side height is 44. So now you can see the scale is not aligned to the dots, means it is not vertical. So you have to take care for this thing. So now this is up to 44. Now this dimension is 38. This is 40, 39 and 38. Now this dimension is vertical line. This is a vertical line having dimension 44 minus 19. So there is no need to calculate this. Simply here you can take one line and draw one vertical line here. Now this is the outline of the object. So our 33% of the task is over. This is just an outline. So you can verify this. This is the outline of the object. 19, 100, 44, 38. This will be 25. Yes, 24. There is error, I guess. 44 minus 19 will be 25. So it should be 25 here. Minor error is there. No issues. You can take care for this thing. So now let's identify the cavities here. Let's identify the cavity. So in this whole object, this is the first cavity. This is the hollow part. Here in the base, only this part is solid part. Only this is the solid part. So 6 mm height is there. So at the height of 6 mm, draw a line. Now this is the hollow part. So there is no hatch. There will be no hatch. Now in this area we'll identify the hollow part. So here there is a cavity of dimension 38 at this cutting plane. At this cutting plane there is a cavity of 38 mm and there is a 13 mm margin from this point. So from here we'll take a margin of 13 mm. You can measure 13. This is 10, 11, 12, 13. After 13 mm there is a cavity of 38 mm. This is 35, 36, 37 and 38. So this is the cavity in the plate. So here also there will be no hatch. Right? Let's identify any other cavity. So at the center of this about this cutting plane, this was the cavity, this is the cavity. Now this is also cavity. And one more thing, this portion will not come in contact with cutting plane. This will not be sectioned because this is away from center. So if you're cutting this object through this path, this area will be unaffected. So this height is 13. This height is 13. So take a point at the distance of 13 mm. This is 10, 11, 12, 13. Now this is unaffected area. This area has no effect of the cutting plane because cutting plane is cutting the object at center. So again, about this cutting plane, there is a circular hole. This cavity is there, dia 10, and this gap is 19, means half of this 38. So at 19 mm, mark the point. This is the center of this hole. So we have to take 5 mm on both sides because diameter is 10. Now this is again a cavity. So here no hatch. In this cavity there is no hatch, and in remaining area will do the hatching. One more thing. What about these two holes, M6, 20 deep? First let's understand what is M6. What is M6? M stands for metric. So here basically we have to insert the screw of M6 size, means metric thread with having 6 mm nominal dia. So here this diameter should be 6 mm, at least 6 mm diameter to accept this screw. So here the dia should be 6 mm. So basically this 6 mm dia will be unaffected because cutting plane is here. It will remain hidden, but in sectional view we are not interested in drawing the hidden lines. So here will not show any hidden line. The reason is we are talking about this particular hole of the object, sorry, this particular section of the object. So that's why we are not interested to draw this hidden line. So in remaining area we'll do the hatching here. Now this scale is at 45-degree angle approximately. You can set it by the protractor also. Once you can set this, I'm drawing this line based on my experience. -45-degree angle from this origin. So this is now 45-degree angle. Yes, it is parallel. Now you can continue these lines. This is the solid area of the object. You have to keep little bit patience here. You can see that with the patience I'm drawing these section lines. These lines are the section lines, and I'm using continuous thin type of line to draw the section lines. This is solid area and this is last part. Now this is the sectional front view of the object. This one is the sectional front view of the object. So let's draw its top view of the object. Let's draw the top view. So for top view, simply the very first step is to take the projection. And here you have seen, with the help of these three steps, prepare outline, identify cavities, and then hatching. We can do the hatching, we can do the sectioning in very simple manner. So let's draw the top view. For top view, simply take the projections first. Take the projection here. From all the turns, take the projection. We'll take the projection from here also. Length will remain 100. Now width of the object is 64. So from here this is 60, 61, 62, 63 and 64. We'll complete this boundary first. You will realize top view is very easy if you will use the projections. Always use the projection. Now we have to define this boundary to make a line here from this projection. Now the picture is coming here. Almost the top view is clear. 50% of the picture is very clear now. So here we have to make the hole, here circular hole and these two surfaces. It's like a trapezium. So here out of 64, this is 24. So this dimension will be, you will calculate this, 64 minus 24. 64 minus 24, so this dimension will be 40. So means both the sides 20, 20. So out of 64, this is 10, this is 20. From bottom also we have to measure 20. 20, these are the 2 points. Let's see this margin. So this margin is given as 13. So if this is 13, this will be also 13. Or you can say 64 minus 38, remaining is 26. So 13 this side, 13 this side. This is 10, 11, 12, 13. And from here also we have to measure 13. Now you can join these points. See, whenever you are watching any video, try to prepare the drawing side by side and also calculate the time, that how much time you are taking. Here I am explaining the drawing as well as I am preparing, so most probably I will take 18 to 20 minutes. So if without explanation you will draw, so you should take around 14 to 15 minutes to draw the two views. So now let's prepare these three holes. These are the two holes. So as per our discussion, this is M6, means metric thread, and this is the hole to accept the screw of M6 thread. That means we can say metric thread of dia 6. Here nominal dia should be 6. So this diameter should be 6 and 6, both the sides, 6 and 6. Two holes, 20 depth. So let's draw the center of this hole. This is 10, 10 this side and 13 this side. 10 this side and 10 this side. From here you have to mark 13 mm inside. This is 10, 11, 12, 13. Here also will follow the same thing. This is the center line. This is 10, 11, 12, 13. So here we'll draw the holes. This is 10, 13. This is 10, 13. It's already given. 10, 13. And this is the diameter 6 as it is given M6. M6 means metric screw having dia 6, nominal dia 6. So we can draw the center of this circle also, this circular hole. So this is at the distance of 19 mm. Means at the center of this object. 64, so this is 32, half of the width. Here we measure 19 mm. Total dimension is 38, so hole is at center. Here first hole, second hole, here third hole. These are 6 mm dia and this one is dia 10. Let's see this hole. So here two semicircles are there. This is 18. So let's calculate this dimension. If this dimension is 18 means this dimension will be 9. So this radius is 9. R9 means radius is 9. So out of 38, this one is 9, this is 9. So this remaining dimension will be 20 mm. I'm explaining this again. Total dimension is 38. Out of 38, this is 20, this is 9 and 9. Because this dimension is 18, so half of 18 is 9 this side, 9 this side. So 9 mm radius is there. 9 radius is there, right? So let's extend the center line. We have to take 9 this side. We will mark one point here and we'll measure 9 mm this side. Similarly, 9 upside and 9 downside. Here also from this point, 9 this side and 9 this side. So let's draw the arcs. Now from the center, you can see from the center, first we'll draw the arc of radius 9. Now this dimension is 18 as per given data. This will become 18. We have to simply prepare the drawing as per the given dimension. So now this is 18 and this remaining dimension will become 20. You can check here. This one is 20. Remaining dimension, and total dimension will become 38. 20 plus 9 this side, 38. So let's draw the dia of 6. Dia 6 means radius 3. So take a radius of 3 mm here. It's very difficult to draw, but here you can use the circle master if you want. Circle Master is easily available in the shops, stationery shops. It having the different sizes hole, so directly you can draw this hole with the help of Circle Master. So this is the hole of dia 6 for M6. M6 means metric thread screw. The screw is having metric thread of dia 6. This hole is of dia 10. So dia 10 means radius 5. Here also you can use the Circle Master. So now this is the top view of the object. So in case if you want to draw the hidden lines, so only this line will be hidden here, this 150 mm. So from the center, we can measure 25 upside and 25 downside. This is 5, 10, 25. 5, then plus 10, 15, 25 this side and 25 this side, means total is 50. So here we can draw the hidden line. So for hidden line we have to use the dash type of line. This is the hidden edge of the object. This is the cavity inside this base, 50 mm, which is not visible from the top. So that's why we are using the hidden line here. One more thing is there. In the front view, if you want to show this hole as a hidden hole, so you can draw it. If you think this is important to represent, so you can use the hidden line here also, right? So for that, simply I'm telling you the procedure. Here is the position of the hole. To take the projection lines, it is given that the depth is 20 mm. So from here this is 10 and 20. So up to 20 mm you can draw the dashed line here. Align your scale with the second edge. So here is the hidden hole after doing even sectioning. So in case this is the sectional front view and top view, still in case if you have any doubt, please post your comments and subscribe to the channel please. Thank you so much.